So I chose bunnies for my organism, and we're going to focus on the gene for hair color. So I created a storyboard to illustrate what's going on. We've got 100 bunnies out of a larger population that live in this deciduous forest. And our scientists are wondering, what if we took some bunnies up north? What would happen to their gene frequencies? So we moved 100 of them up north to Canada, and we're wondering if the environment, the snowy environment, is going to select for the albino type bunny. So they're allowed to mate for a bunch of generations, and then we're looking from the initial populations what has changed here. And the results are what we're going to evaluate in the next couple slides. So before selection occurs, we have 52 albino, 36 tan, and 12 brown bunnies, and we know we're in Hardy-Weinberg equilibrium. We have a large population, and all these factors our scientists are controlling. So we've got our reference numbers here, and then we're finding out our allele and genotype frequencies. So to find our allele frequencies, we've just got to find the number of big H's in the population out of the total number of alleles, which is 200, because every bunny has 2 alleles. And that's how we get these 2 values, our P and Q values. And for our genotype frequencies, all we have to do is find the number of a certain genotype of bunny out of the total population. And that's how we get these 3 numbers right here. This is just a chi-square test to prove that we are in Hardy-Weinberg equilibrium with our initial population. So we've got our initial frequencies here, we've got our fitness values here. This is directional selection because we're selecting towards big H, or little h. Little h, it has the highest fitness value, and we're going down in fitness as we go down the line, little h, big H, and big H, big H. For unadjusted survivors, we multiply initial frequency by our fitness values to get these values, and then we add all those up to get our W bar values. We divide our unadjusted survivor values by our W bar value to get the frequency after selection, and that's how we make all these 3 numbers add up to 1. So these genotype frequencies we found in the table. For the allele frequencies, we just add the genotype frequency for big H, plus a half times big H, little h. We're finding our big H allele. We have 2 big H's and 1 little h here, so that's why we add those up, and we do essentially the same thing for little h. And if the population is continuously selected in this way, then we're going to end up with all little h bunnies eventually. Thank you for watching.